right, we'll just try out by using this topic on the acid, bases, and salt. I remember that time you told me you need a bit of help on the salt prep, that concept, right?
Yes.
Okay. So, can you tell me more about the your chemistry results first?
I failed it by 1 mark. So out of 80, I
Mm-hmm.
got 39.
Okay. So that is only for the is the entire paper,
Yeah.
or was it just paper two and paper three? Paper two.
It was the entire paper.
Entire paper. Okay. Pure chem, right?
Mm-hmm.
Okay, sure. So in that paper, you have browsed through. What are the things that you're not very sure?
Like,
Like, is it application
yeah, it's
or is it
application.
applications? That means when a question is given to you, you find it a little hard to you find it a little hard to apply the concepts to it lah. But could
Yes.
you understand when you read the questions?
Sometimes.
Oh, sometimes. Okay, okay. All right. Then tell me more about your daily test and also um the daily test. How have you fared for those tests?
Uh, it's always just like a borderline pass. Yeah.
Oh, so you managed to pass lah on
Yeah.
those periodic tests.
Yeah.
Okay, okay. Can. Got it. Okay, lor. So let me just run through with you on the concept first. Very well, so far can hear me very clearly. No lapse time, right?
Yeah. No lags.
Good. Yeah, you tried using Skype before,
Mm-hmm.
Yeah, okay, can. So for the So you see, if let's say you have anything to share with me, you will need to use your own Zyteboard, which I think I've given your mom the link that day.
Mm-hmm.
You
Mm-hmm.
can upload those informations on the board, then we can even share the board as well.
Okay.
Yeah, all right. Okay, so let me just run through with you on the salt prep first. Now, basically for the whole chapter on this acid, bases, and salt, you have to divide it into three parts. All right, that means you're going to understand the concepts of the acids, the bases, and the salts first. Give me a minute. Okay, so in this part on the salt, basically we are making use of the reactions between the acids and the bases to make the salts. And of course, not just making salts through these reactions, you also need to know the correct method to make the different types of salts. All right, so that's why before you go into the salt prep concepts, you need to know what are the theory or the concepts for the individual type of acids and the bases. Now, when you study about the acids, right, could you understand this section?
Yes.
Okay, so nothing new. It's quite similar to what you have learned in Sec 1 and 2. You need to know about the definitions of the acids, their physical properties. So I'll leave it to you, quite easy to understand. All right, but this part, which talks about the chemical properties of the acids and the chemical reactions, are the most important concept for the acids. All right, so just run through this briefly first. So we have the acids and matter with the salt and hydrogen. Now take note that for this reaction, acids and matter, they will, you only need to take note that unreactive metals, they don't react. For example, copper, silver, and gold. All right, copper, silver, and gold, they don't react with the matter. Yeah, could you see me?
Yeah. Yes.
Oh, okay, can you can see it now, right?
Yeah.
Okay. All right, so let's carry on. Now for the acid and matter reactions, three metals, copper, silver, and gold, they don't react with the acid. By the way, I'll be
Mm-hmm.
giving you these notes later, okay?
Mm.
Yeah, so you can't see this, sorry, you don't, okay, these three metals, they don't react with the acid. However, some exceptional cases you got to take note. These three metals, they can react particularly with nitric acid only.
Okay.
Let me see if I can write something here. I'll try. For example, if you have copper, okay, copper is an unreactive metal. Now, copper can react with the nitric acid.
Mm-hmm.
Now, the reason for this is because nitric acid is a very strong oxidizing acid. Now, as in the equation, you don't have to learn how to write the chemical equation because actually this is not in our syllabus. But then it's good to know because it came out a number of times in different school prelim papers. So what happened is when it reacts with the copper, nitric acid reacts with copper, it gets you to the copper 2 nitrate, which is a salt. But then the other byproducts are different. In fact, it will form nitrogen dioxide, all right,
Mm-hmm.
nitrogen dioxide, and also the water. Yeah, so that is something you need to take note. Okay, so similarly, if you have your silver to react with the nitric acid, it will form silver nitrate and the nitrogen dioxide NO2. Now I know that the stylus is so wonderful. Okay, I'm trying to draw things on this. Okay, anyway, just take this. So once again, this salt solution will also be a blue solution. All right, so unreactive metal will react with nitric acid in this manner.
Yeah.
Okay, but if you use other acids, no reaction at all. Okay, let's move forward. You have the acid plus the base. That is a neutralization reaction. You have a salt and the water. And then acid plus the carbonate to give salt, water, and carbon dioxide. All right, so these are what you have learned before. Any questions so far? No.
No.
Okay, now the next part of it will be the bases. So you have learned about bases. Could you understand the difference between bases and alkaline?
Not really.
Okay, now basically for bases, we have to divide it into two parts, the soluble bases and the insoluble bases. So soluble bases are known as alkalines. Yeah, so how do we know what are the bases that are alkalines and what are the bases that are insoluble? It's a guideline. All the group 1 metal oxides, by the way, bases are known as metal oxides. Must be a metal with an oxygen. All right. So for all the group 1 metal oxides, they are all soluble in water, very soluble in water to form alkalines. So the solution that we get, right, is actually known as the alkalines.
Yeah.
For example, if I have like sodium oxide, Na2O, okay, and you add it on to the water, H2O, it gets you to NaOH. All right, so NaOH is the alkaline. Got it? So only group 1 metal oxides are. Now then, group 2 metal oxides will also have some solubility, but then the solubility is very, very low. For example, you know what's lime water? The
Yeah.
lime water that we use to test for the carbon dioxide, right? Now it's actually made from calcium oxide, dissolving in water, H2O. But then, did you realize that all the time, the lime water will always be milky, chalky? Why? Because the calcium oxide is not very soluble in water, sparingly soluble, all right? And then it forms the calcium hydroxide, indicating that actually this calcium oxide, yes, is soluble, but not as soluble as those group 1 metal oxides. Good
Mm-hmm.
to know this. Yeah, that's why your lime water always appears chalky lah. Even though you don't bubble your carbon dioxide, it will still be chalky like that, in appearance. Right?
Mm-hmm.
Okay. Yeah. So what happened is that for this solubility on this calcium oxide, an exception, take note. But the other group 2 metal oxides, usually we don't consider them to be good alkalines because their solubility is pretty low in water. Yeah, so then we will consider them to be the insoluble bases. Okay, so of course, other metal oxides like maybe transitional metal oxides, they are also considered to be insoluble bases. So you just call them bases. Then alkalines are soluble bases, which are the ones that I've mentioned to you earlier on. Okay, so this one must get it clear first. Okay, so knowing this, you can see that what I've mentioned are all written here. You can take a look at it. All right. Okay, then physical properties of the alkalines. You have this, yeah, all the properties that you've learned it before in Sec 2. You take chemistry in Sec 2, right?
Yeah.
Okay, okay. So have some background on it. What's your CCA in school?
Choir.
Oh, choir. Okay. And you're from which school?
Nanhua.
Oh, Nanhua, the one at Clementi.
Yeah.
Okay, it's a good school. Yes. All right, so let's move on. So now you know what's the difference between alkaline and the bases. You can then understand the reactions of the alkalines. Now, basically, alkalines can undergo neutralization reactions, such as the reaction with the acid. So there are some examples at the bottom. But then alkalines can only react with ammonium salt. All right, so this second reaction is only referring to alkalines, not bases. In other words, if you talk about insoluble bases, for example, the zinc oxide, or maybe aluminum oxide, or probably titanium dioxide, they cannot react with ammonium salt. Can? Yeah, okay, so this is only meant for alkalines. And of course, all the bases, whether they are soluble or insoluble in water, they can undergo neutralization reaction. All right? Okay, so these are the two reactions because you can use them to make salt. So far, okay? All right. So this one put on hold because you don't need to know about the strong and weak acid to understand the salt preparation. I'll come back to you on this probably next lesson. All right, today is just a trial first. So far, are you comfortable with this? Clear or not?
Yes.
Okay. And you have a reading session in school. Was that over already or still ongoing?
It's over already.
Oh, so what did you all learn for chemistry?
We're learning on metals.
Oh, matters. All right, that was what I've been teaching the students during my ongoing class as well. So you finished the whole chapter on matters?
No, we started a reactivity series.
Oh, reactivity series. Okay, and you stopped there? You have not moved into the extraction of matters?
No.
Okay, okay, no problem. So if there's time in the holiday, I'll go through with you on that. Then probably later on, we'll need to sort out some schedule with you to run through, as in to set some dates for the subsequent sessions. Okay, anyway, you have this. Let me see. Okay, we're going to go into this now. Have you have any hands-on on the titration before?
Yes.
Have, right?
Yeah.
You know what titration used for?
Soluble salt.
Oh, good. Okay, particularly which salt? Which
What?
soluble salt?
Uh, like if their two reagents are soluble.
Very good. Okay, two reagents, they are soluble. And in fact, when you do titration, right, you're actually making either the group 1 salt, group 1 soluble salt, or ammonium salt. Yeah, because when you talk about soluble salts, right, there are many, many different types of soluble salts. Some of them are non-group 1 soluble salt, some are group 1 soluble salt. But if you want to make group 1 soluble salt, you can only use the titration method. Okay? All right, so let's see. Okay, now before you go into the different methods of making the salts, right, you need to remember the solubility of the salts. Remember you have a chart, a small table that talks about all nitrates are soluble and then all carbonates are insoluble except for the group 1 and ammonium carbonate. Yeah, okay, and then you talk about the sulfate as well. So could you remember sulfate? All sulfate soluble except for?
Lead 2.
Yeah. Lead 2. So you have your lead, you have the barium, and the calcium.
Yeah.
So usually they use this abbreviation CBL or CLB, sorry, CLB, the Chinese language basic. So C stands for calcium, L stands for lead, and then B stands for barium. So these three metal sulfates are insoluble in water. Yeah, but the rest of the sulfates are soluble. So what about chlorides? For chlorides, right, all soluble except for the silver and also the lead 2 chloride.
Okay.
Okay, so once you have memorized the solubility table of the various type of salts, right, then you need to choose the correct method. Now, there are only three methods of making a salt, and they are see the flow chart. First, you have to identify the solubility of the salt. If the salt is soluble in water, okay, then you can make the salt by going through this either of these three types of reactions. Can? Okay. Then the next question you need to check is, are the starting materials for making a salt soluble in water? So if let's say they are soluble in water, like what you've mentioned just now, then you have to use a titration. Basically, this pathway, right, allows you to make the group 1 or the ammonium salt, right? Group 1 or the ammonium soluble salt, right? Okay, but then if the starting materials are not solutions, that means one of them could be a solid or the other one may be a solution, then you have to use the adding and excess method, which is this method number 1. You see that? So this part here, this part of the flow chart is to explain to you how to make soluble salt. So titration only for group 1 or ammonium soluble salt. This one are the rest of the non-group 1, non-ammonium soluble salt. Okay, then this part of the flow chart, there's precipitation, is used to make the insoluble salt. Yeah, insoluble salt. So let's talk about this precipitation first. Yeah, what do you understand about precipitation?
Like the reagents have anions and cations.
Okay, of that salt that you want to make, right?
Yes.
Yes, okay, and then the other criteria is that the reagents have to be both soluble. So there are many ways. There are many ways for you to make the same type of salt. Let's use silver chloride as an example, which is an insoluble salt. Now, if you want to make silver chloride, you can choose to, let me write it out here. You can choose to use a nitrate. Now, actually, nitrates are very good starting materials for making insoluble salt because all the nitrates are soluble, right? So you can use nitrate as a starting material. But what kind of nitrates to be used depends on what salt you want to make. For example, if I want to make silver chloride, I have to use a silver nitrate. Okay, I cannot go and use sodium nitrate or maybe other nitrates because these do not have the relevant cations that I need to make the insoluble salt. Okay, so like this one is silver nitrate. All right. Then, okay, now this second reagent, we have many choices. As long as it is a soluble chloride, then it will allow you to make the silver chloride. So you can use things like sodium chloride. This is the classic example. Or you can use hydrochloric acid. You can even use magnesium chloride, any soluble chloride. But the chloride must be soluble. So these two starting materials have to be in the aqueous state. Then it will give you the silver chloride, which is the main product. You can see my writing, right? I'm going to get a stylus. Okay, so you can make this a silver chloride or as the main product, but the side product, that means the product is not important one, will vary because it depends on what reagent you are using it here. Make sense?
Mm-hmm.
Okay, so that's how precipitation works, lor. Then remember, you also need to memorize the steps in describing how precipitation is being carried out. Then we say that the starting materials, mix them together. Now it will not be equal amount, it can be random amounts, because this reaction is a very spontaneous reaction. Spontaneous means that you will get the products immediately.
Mm-hmm.
Okay, so that's why there was one questions in one of the prelim papers that I came across a few weeks back from one of the students. They talk about the rate of reaction. That means you're going to compare the rate of reaction out of these three types of reactions. The first one is precipitation. Second one is a reactive matter with the acid. And then the third one is a reaction which is the polymerization. So they say which reaction is the fastest? In fact, precipitation is the fastest reaction. Because when you mix the two solutions together, right, it will just give the products immediately. Okay. However, if you talk about reactive matter with acid, right, you don't get a product immediately because the acid and the matter will still need to take a few minutes to react completely, then you will get the final product. Although reaction is very vigorous now. So that is the reason why we don't need to use a fixed amount of these two reagents, but we can just mix them any amount, we will get the insoluble salt. Okay, so precipitation, you just go and memorize the step-by-step method. That means you add them, then stir well, then what do? Do you remember? What's the next step after you get the precipitate? How would you separate from the mixture?
Do you filter it?
Yeah, you're right. Okay, you're gonna filter it. So you filter and then wash the residue with the distilled water and dry between the filter paper.
Mm-hmm.
Okay, very simple lah. All right. So this precipitation, there's one more thing you need to take note. How to write the ion equation for the precipitation. There's actually a method. You know what's the method? You see, this is your insoluble salt. Whenever they want you to write ionic equation of an insoluble salt, right, you take the cations and the anions of the insoluble salt, like that. Okay, Ag plus Cl minus. These are the respective ions that are found in this insoluble salt, right?
Mm-hmm.
You put them together and then you get this ionic equation. Okay, and then the stick symbols are also a standard ones. Aqueous plus I can't do it. Wait, hold on. Okay. Aqueous. Okay, aqueous plus aqueous will give you a solid here. Alright, so all those stick symbols are also a standard ones because you know that the starting materials have to be both soluble. So you aqueous plus aqueous, and that will get you to the insoluble salt, which is a solid. Now the byproducts, the not so important products, do not appear in the ion equation because all these ions are spectator ions. You see our nitrate and the sodium ions are spectator ions. They don't take part in the reaction at all. So the purpose of writing ion equation, not just for this reaction, in any type of reactions, when we want to express the reactions in the form of ion equation, the objective is to find out what are the important and the participating ions. That's the purpose of writing out the ion equation. Okay, so that's the method lah. Like for example, if you want to write out the ion equation for an insoluble salt, like maybe calcium sulfate, so it will be Ca2 plus SO4 2 minus to give CaSO4.
Mm-hmm.
Yeah, then stick symbols the same, aqueous plus aqueous to give solid. So far okay?
Yeah.
All right. Okay, then the last part about precipitation, you need to note, I can see like this one method like very simple, right? But it seems like there are many things that can talk about it. Yeah, the other part of the other concepts about precipitation that you need to know will be this. Hold on, let me see if I can. Okay, good. You have WhatsApp, so probably I'll send this questions to you through the WhatsApp as well.
Okay.
From the WhatsApp, you know how to download the questions, right?
Yeah.
Okay. Wait, let me draw out the questions first. Okay, there is a very popular questions about precipitation. Okay, not much code. Will you be having any more school?
I
No.
still have some CCA.
Oh, your CCA, you're participating in some of the competition or performances.
Like performances and open house.
Oh, open house. What's your voice range?
Auto?
Oh, wow. Auto is the low one, is it?
More like
The
medium, I guess.
or medium, Oh yeah, where is the question, How come it's not uploaded? Hmm. Let me see. Where is it? Okay. Oh, yeah. Okay, question 39. Did you see it?
Mm-hmm.
Okay, now this is an O-level question. It says, which of this equation that represents the reactions of the dilute sulfuric acid is not typical of a dilute acid? All right, now what do we mean by not typical of a dilute acid, right? Is that this acid does not behave like an acid. That means it doesn't use its acidic properties to take part in a chemical reaction. Now, what do you understand about the definition of acid? We say that acids are substances that gives out the H plus ions when they are in the aqueous solution.
Mm-hmm.
Okay, so in other words, when we say that the reaction is not typical of a dilute acid, right? It means that this acid does not use its H plus ions in the chemical reaction. Or we can say that the H plus ions are not the participating ions. They are just the spectator ions. You get what I
Mm-hmm.
mean? Yeah.
Mm-hmm.
Okay, so for this kind of question, right, you will see that usually the precipitation reaction are the one that does not show the acid as being the typical acid. For example, if you talk about the equation C, that means the option C, right?
Mm-hmm.
Can you see that this is a precipitation reaction because of the formation of the insoluble salt, which is the lead 2 sulfate, all
Mm-hmm.
right? And then the starting materials are both aqueous, which means that this precipitation reaction is feasible, is spontaneous to take place. And we know that for the lead 2 sulfate, right, to be formed, the ion equation that represents this reaction will be Pb 2 plus, we take the cations and anions, combine it together, all right, and the SO4 2 minus to give the PbSO4, correct?
Mm-hmm.
But you see that, right? Okay, you understand what I'm trying to say?
Yeah.
Okay. All right, so can you see that in the ion equation, H plus ions are not even taking part in the reaction at all.
Mm.
So it shows that this acid is not behaving like an acid. It doesn't use its H plus ions in the chemical reactions. That's why this is the answer. So, like in the example that I have shared with you just now, where is it? It's gone. Ooh. Remember just now we talked about the silver chloride, formation of the silver chloride, right? And then
Yeah.
yeah, and I've suggested to use the silver nitrate and also the hydrochloric acid.
Mm-hmm.
Okay, so in that reaction, hydrochloric acid is also not behaving like a usual or normal acid. It doesn't use the H plus ions in the formation of the silver chloride.
Mm-hmm.
Got it? So this one must know, lor. Alright. Well, I think it takes a while to load the question, is it? Any questions so far? Do you understand?
Yeah.
Okay, good. If you understood means that the Skype works. Ooh, good. Alright. Yeah. Okay, however, if you look at the other options, you will see that the H plus ions are participating in the equation. Could you write out an equation?
Yes.
Okay. Probably you have paper and pens with you?
Yeah.
Okay. Could you try writing out the equation for option D, the R equation? Can you just show it to me? There's a mistake, right? It will correct you and then you
Okay.
ones you want me to go through.
Mm.
Yeah, we're trying to because this is need to adding acids with alkaline. I can use calcium with hydrochloride. Get water, right?
Yeah.
Yeah. Solid reactant in excess. The calcium chloride. us here. The answer. Reactive matter. Its reactivity is even lower than